unscrewing one of the eye bolts from the turnbuckle. Then, I take the spark plug and carefully slide its threaded end through the eye of the bolt. To make sure it's completely secure, I'm adding a series of washers and nuts. I tighten everything down firmly. This is crucial because a solid, stable base is required for the pressure we'll be applying later during use. This is going to form the main head of our new tool. Once it's tight, I screw the assembly back into the turnbuckle body, which now acts as a sturdy, comfortable handle. Next, I take a piece of thick red electrical wire and strip the ends. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I'm wrapping one end of the stripped wire around the top electrode of the spark plug and tightening it. I use pliers to twist it tightly. This ensures a strong, continuous electrical connection, which is the absolute heart of this project. At the other end of the wire, I'll secure it to the threaded part of the spark plug. This completes a localized circuit path on the tool itself. Then, I prepare a much longer piece of red wire, stripping the end to create our main power lead. I wrap the exposed copper of the long power lead around the main threaded body of the spark plug. I make sure to twist it down as tightly as possible. A weak connection here would cause unwanted resistance and heat up the wrong parts of the tool. Now, I'm wrapping the entire metal handle with red electrical tape, making sure to secure the long wire alongside it. This is super important for insulation and safety. It gives me a good grip and prevents any accidental short circuits or shocks when the tool is powered up. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. On the other end of our long red power wire, I strip the insulation and attach a sturdy alligator clip. I use my pliers to crimp the metal tabs securely over the wire. This clip will allow us to easily connect our tool to a high current power source. Now for a really cool part. I'm taking a dead, heavy-duty AA battery. Using my pliers, I carefully cut open the metal casing to extract the solid carbon rod from the center. I wipe off all the chemical residue. This carbon rod is highly conductive and can withstand extreme heat, making it the perfect heating element for our tool. To make the tip precise, I chuck the carbon rod into my power drill. As I spin the drill, I use a piece of sandpaper to meticulously sharpen the tip to a fine point. This focus point will allow for precise heat concentration when we start welding. I attach a small brass terminal block to the top of the spark plug. Then, I slide our sharpened carbon rod into the block and tighten the screws. This holds our heating element securely in place while allowing maximum electrical current to flow directly into it. I'm preparing a separate blue wire with an alligator clip to act as our ground line. It's time for power. I'm using a standard 12-volt car battery. I use a multimeter to verify it has a good charge. Around 12.9 volts is perfect. Car batteries can deliver the high amps we need to generate intense heat. I connect the red alligator clip from our tool to the positive terminal of the battery. I connect one end of the blue ground wire to the negative terminal, and test the circuit by touching the other end to the base of the spark plug. We have a spark. The circuit is live. I've placed two pieces of utility blade overlapping on a wooden block. I attach the blue ground clip to the metal blades. Watch what happens when I touch the carbon tip to the joint. The extreme heat instantly melts the steel, acting as a powerful homemade spot welder. Look how perfectly it works. As you can see, the weld is incredibly strong, fusing the two steel blades together solidly. But that's not all this tool can do. Here I have two wires and I've twisted the two copper wires tightly together. The concentrated heat of the carbon rod acts like a mini soldering iron, easily melting copper and soldering two conductors into a strong joint. The heat control is surprisingly good. I'm taking a small AA battery, securing it with a clothespin, and creating a contact point with a blue alligator clip. When I touch the heated carbon rod to the AA battery, the metal quickly heats up and melts, helping to secure it to the battery. This demonstrates the incredible energy concentrated at the tip of our tool. The heat transfer is fantastic, melting the solder instantly for a perfect strong joint. And there you have it, our incredible multifunctional welding and soldering tool, made from a simple turnbuckle and spark plug. If you enjoyed this project and found it inspiring,